I want to thank all of you for coming today. It's already been a great start to the morning. We have a pretty awesome panel of professionals here operating in the industry. What we're going to try to cover today is what are the really key kind of developments in technology and manufacturing about agrivoltaic systems happening in the province, well, happening in Canada rather, and essentially how can we learn more about it. So from Polar Racking, we have a Dikran Ghorgorian, and also from Polar, we have Sam Alradhi. From VCT Group, we have Zach Jolliffe, and from Food Security Systems Canada, we have Kim Parker. So thank you all for joining us. So I've got a couple of themes. What I'm hoping to do is kind of run this like a conversation, but we're also going to have some slides kind of intermixed. So this is my first time running it kind of like this, but I thought the first thing we could talk about, since we've already seen some pictures of agrivoltaic system designs, Uzair talked about them a little bit. I just wanted to give the panelists an opportunity to talk a little bit about how they design and engineer agrivoltaic systems in Canada. We have different climatic challenges here than in many other countries where agrivoltaic systems are already happening. So perhaps if we can just start with Polar and kind of go around first. You guys can talk a little bit.
Hi. So we're a racking company. Polar Racking is a racking company. We're not in agriculture. We're not in bio or any other different industry. So we are trying to bring the racking to agrivoltaic, basically. And it's a balance, basically. The way we understand it, agrivoltaic is a balance between generating power and also bringing humidity and irrigation or underneath so that we can grow plants. So we would need a lot of collaboration from a lot of different groups just to get the better understanding, because we're going to be showing you a few slides in terms of what we came up with and what we're doing. But again, more input that we get, better designs and more efficient designs we will provide you.
Actually, Zach, maybe you could talk a little bit about designing for the Canadian climate.
Sure. Hello, everyone. My name is Zach Jolliffe. I work with VCT Group. Very happy to be here today. I'm not an engineer. I'm marketing and sales, and the engineering team at VCT might laugh a little bit that I'm the one explaining this to y'all, but I'll do my best. So we're not a racking company. We're traditionally a solar EPC, but we've developed our own solar canopy product, and it is designed for a Canadian climate, though it can work well in other places as well. I'll show you more when we get to some slides, but we've got a patent pending on a water handling feature that's built into the canopy, so we can handle drips that might come through between panels, and we can collect that. It can be harvested for irrigation or for gray water, or just sent to stormwater if needed. And I can kind of get a lot more into the design story, but want to be cognizant of how much time we have to work with here. But about 5 years ago, we built our first solar canopy. It was someone else's product, and the product was discontinued after we finished that installation. And at that point, we embarked on our own design journey to build a solar canopy product. And one of the things we knew we wanted to solve for was water handling. And it's a key part of our design and something that we feel like we can bring that's unique to the Canadian market.
Okay. Just introduce myself, I guess. I'm Kim Parker. I am the president and CEO of Food Security Structures Canada. And like Zach, I am not an engineer. I am the business side of the business. Well, I'm very blessed to have an amazing chief technology officer who is our specialist in our technology. What I'm here to share today is a very exciting project that we've been working with Dr. Pierce and his team at the university, which combines our controlled environment agricultural structure with an agrivoltaics system. We are very lucky to be working under a Weston Foundation grant to address the bringing. Right now, I believe the number is 85% of Canadian berries are imported, and the challenge grant that we were one of 11 teams to win is focused on bringing that production back here to Canada to reduce our dependence on imports, and agrivoltaics is going to play a very critical role in that solution. And I've got some great slides I'm going to show you about that this morning as well.
So why don't we actually look at some of those slides now? I know Sam or Dikran, maybe if you guys could elaborate a little bit about how you've been designing different and trying to customize solar structures for different agricultural applications.
Yeah, so hey everyone, my name is Sam. I'm with Polar Racking, and to Dikran's point, we're a racking company. So this is not like something that happen overnight. We've been in the business for 15 years, and we've been mainly like working in harsh and extreme weather conditions, which is Canada, sadly. But we've been in the northeast of the U.S. and Alberta, Nova Scotia, and you name it. So, like understanding to the point earlier, understanding the cold weather and understanding what it takes to design a product to withstand those conditions, and not only that, to help and make it easier for installers to install in such conditions. So, putting our head together with a few of the feedback from even like we worked with Dr. Pierce a little bit, and we worked with a few of the developers that gave us feedback and gave us input on their needs of the products and what they saw in some areas they liked and what they disliked. So we came up with a few designs. One of them is what you're looking at, which I think Uzair showed in the earlier slides. We call it the fence design, and it's we're actually selling this right now in Alberta, and it's going to be built in early 2024. Not to go too much into the design, but this one is one of the easier applications to install because it's just basically it's foundation design. It's some purlins, and you attach the solar panels to it. But it's a very easy application to install and cost friendly. Did we have another slide? And sorry, did you want to?
Maybe you can.
I'll let you take this one.
To understand better in terms of what we can do to make our racking more efficient, we basically compared very different types of racking that we have, and we basically designed the fence also as an addition to see like in what case you would make more power. And as you can see, like the blue one on the top is like the tracker, and which brings, I guess, with the tracker comes, I guess, more power. But if you go and face southwards, if you get a fence design and face it southwards, we found out to be like more evenly distributed, the yellow. And when you have it like east-west, basically during November, December timeframe and January, February, you find it to be less. Now, there's like the green and the blue, as you see there, the light blue. Those are the fence design where we had like either blocked in one side, the previous slide that we had, where you had a beam going and blocking the sun, or having like omega rails basically and clearing the site. So it's fairly close to each other, and we're trying to get that on top of each other, by doing more designs. But from what we're trying to do is to put also some pipelines on top of the beam, on top of basically the panels, so that we can do irrigation. We do have certain designs like 4-inch diameter, basically tube going all the way, and the racking supporting it. But you have to also understand from structural perspective, when you are vertical, and wind will blow 100% directly perpendicular to your panel. So you would need, your foundation and everything has to be fairly strong, and especially because of agrivoltaics, you have to raise it up 4 or 5 feet from the ground. That's going to make it even worse. So you have to get good size piles to put in. So we tried to do a lot of different things, like going L shape, like the either portrait or landscape, 4 panels, 6 panels, 10 panels, to see like which one will be the most efficient one. And we came up with what we previously showed with a 12-panel, 3-post design.
Do you want to talk to some of the other styles?
And yeah, and what we've seen again, this is the production. We kept the fixed yield as being a common denominator, our baseline. Fixed yield meaning 30-degree tilted, basically a fixed yield racking. And if you compare it with the fence design that is facing east, you have like east will provide 3.3% more power than the fixed yield. If you're looking at the obstructed one, that is 0.9% or 1% less power it will provide. And if you look at the fence that is facing south, that will give you about 6.3% more power than a regular fixed yield. And the tracker, of course, it's going to give you the most, which is 20.5%. Next slide, please.
Important to note here that all of this was based on bifacial.
Yeah, these are all bifacial design, and the same, we always kept the same number of panels, the same number of modules, the same type of module, just to do the comparison. And the next slide is also an important one. This is strictly for Alberta. Like, I tried to get information in terms of how much power costs in Alberta, because some of our customers informed us that in the morning hours and in the evening hours, you get like triple paid for power. And at noon, it's like 1-to-1, basically. So what we did in the morning, 2 hours, and the evening 2 hours, we multiplied the power generated by 3 times. And if you compare it again to the fixed yield, you see like the fence facing east is creating 27% more power than a fixed yield, 24.8 with an obstructed one. The facing south one, which was generating more power if you take 1-to-1, but since you're multiplying it by 3 in the morning and the evening, the facing south is only giving you 17.1, and of course the tracker 32.3%. So that kind of tell us like what we need to do. And every region may have a different requirements. And we have to put all that together basically with understanding of irrigation and understanding of where the pipes needs to be, like on the ground, on the air, how far up in the ground, and how much of water we have to pass through those pipes, so that we can actually design the most efficient design for you.
I'm just going to skip over the other designs, okay? So Polar had also designed or shown a couple of additional pictures. We're running out of time, so I'm going to kind of just show them. No, that's okay. We started 15 minutes late, so now we're trying to accelerate the process. But they do have a number of designs for different applications.
Yeah, we have. So we have like trackers, 2P trackers, 1P tracker. We have the umbrella type, which you saw the picture there, or the tracker, multi-tracker portion on the canopy. And again, everything is, we're going by customer needs, customer wants, and we are having also difficulty understanding everybody wants something, We should basically put this all together in terms of what is really needed for agrivoltaic and where, in which area, what is more important than the other to come to a common denominator.
Thank you. So I thought we'd switch gears a little bit and talk about innovation and how we kind of combine technologies together. So I'm going to have Kim come next. She's going to just talk about how the technological advancements in the structures that they're designing can really deliver value around both energy efficiency and crop growth.
Okay, so how do you take agrivoltaics and partner up with controlled environment agriculture? So what our company does is design growing systems that can handle any climate, particularly extreme climates. Focused primarily here in Canada at this time, but we have a number of projects that we're working on around the world that are also looking at extreme heat climates. So I'm really thrilled to share with you our I was going to say Dr. Pierce, we put this name on it. I'm having a hard time saying it. Agri-tunnel agrivoltaics hybrid for sustainable food production. So let's share a little bit about that. This is our movable agri-tunnel. We were originally proposing our permanent build structure that was going to go to the research farm just north of the city here. But during the course of the actual development and waiting for the funding under the grant that we'd applied for, we were actually working on a movable unit. And the reason was the feedback from the consumer, the communities that were using these systems, the mobility was important. To be able to quickly deploy into a remote community to help address food insecurity, and then the ability to relocate if necessary. So we have developed a technology that works with a fiber reinforced polymer, so think really thick plastic. I use the example, and again, I'm not the techie. I know my techie people would kill me for this. Think of a really thick boat hull. And this is what the unit is made of on the inside. It is smooth, it is reflective. We have special coatings that go on it to, again, assist with reflectivity for the lighting. The unit is insulated to whatever the need is in the community. So standard, we do about an R40, but if we were going to the far north, we would go higher. What's really important to understand about the unit that's different than, say, shipping container units that people are trying to repurpose those type of units. This unit, when you insulate it, you are not losing growing space on the inside. So as you can see, this unit in just over 1,000 square feet has the capacity to have over 11,000 plants. This is high density vertical growing. The unit is manufactured on 2 trailers, moved to site, sealed, attached together. The wheels stay in place to create a semi-permanent build. So this unit could be deployed in an urban application, in a parking lot. It could be deployed on farm, so farmers can have an additional source of income on 1,000 square feet that they're not currently generating income from. It can also be deployed, it's light enough that it can travel on ice roads or on barges to get into far north communities. The unit, once it's on site, is sealed down the middle, and then we build out the growing systems inside. So the unit that we are working on with the university actually landed at the university site on Friday. It was quite an exciting day for us, seeing these 2 great big trucks come pulling in with these units, attach them up. The truck driver, got to tell you, man, he was amazing. He had those 2 trailers within an inch of each other all the way back. Like, talk about skill sets. The unit is being built right now. We are in the middle of doing all of the sealing on the inside, sealing on the outside, getting all the electrical hooked up, and then we start to build out on the inside. Inside of our unit, we are using truly vertical aeroponic growing walls. Each of those walls hold over 720 plants. The lighting for these units to be able to do such intense, dense growing is very special, and it's a lighting system that we have developed. It was a system we were actually working with a company out of the US. Unfortunately, they shut down during COVID, so we thought in the middle of COVID, what a fun thing to do, let's start a lighting company. So that's what we did under our Better Grow Lights brand. We are now manufacturing those lights ourselves. They are a unique spectrum, combination of daylight spectrum, far red, and our own proprietary cellular penetrating chipset. And what that basically means is it's working with the plant at the cellular level. I'm sure some of you have seen the medical lighting that's all the rage right now on stimulating at the cellular level to help cell generation. We're using the same type of technology to work with the plants, to help them grow and optimize their growth without stressing them. I like to compare our light to that beautiful first thing in the morning, gentle daylight, as opposed to the harsh light of the middle of August at high noon. Okay, we're not throwing massive amounts of heat at them, and this is very important with the agrivoltaics angle, is that our power consumption is significantly less. That allows us, with our 24-volt DC lights, to work with an off-grid solution. We are also going to be working on a bin system. We do have a bin system, which you can see on the right here, that we're doing plants that need more height, more root depth. This unit in particular, while we are going to be working with berries on it, this is going to be a very important piece of technology because in northern communities in particular, root vegetables are in high demand and are extremely expensive. This is not a technology. I would not be growing root vegetables down here in southwestern Ontario where you can buy 10 pounds of potatoes for $3.99. One of the communities we're working with in the north, 5 potatoes are $25. Okay, so now, again, when you look at scalability and return on investment, that's where it becomes priority. And I think that's it on my slides. For us, the focus on agrivoltaics outside of the unit, as you saw on the very first slide, we're combining technology, and that's where we believe that there's the real strength here, to capture the power of the sun, to power the controlled environment unit, while also growing underneath the panels outside, really maximizes the ability to produce food for communities, both here in Canada, but as I say, we're working around the world, and while we feel the pressure of climate change here in Canada, the pressure of the cost of electricity, it's nothing compared to what's happening around the world. We have clients in Australia, in Spain. We're working with a consultant that's working in the Middle East and Northern Africa. The pressure that is being felt on the food systems there is tremendous, and I believe Canada is very well positioned to refine this technology in our extreme climate and then bring it to other communities around the world.
Thanks, Kim. I mean, this application of indoor growing environments really allows you to maximize both the energy efficiency, but also the moisture content. It kind of leads me to thinking about what VCT's group is doing with their water management system. Zach, do you want to show everybody?
All right. So, like I said, we've got our own solar canopy solution that we're actively trying to get more of them out into the world. So if you have a building or a parking lot or a farm and you want one, you come talk to me after. So working through a couple renders here. We have built these in real life too. I didn't bring any pictures because all the projects that we've done so far are focused at parking lots. Part of our company philosophy is using underutilized spaces better. And parking lots is definitely a fit for solar canopies, but there's room in agriculture as well to make more use of some of the spaces, and that's why we're all here today, right? To talk about where those synergies are. So this is our single pitch canopy design. We can get excellent clearances both side to side and above ground, so we can work with industrial and agricultural equipment and get some covered outdoor storage and make use of some of the easy to use spaces on the farm. Right now, we know that there are land use things that are getting sorted out. And some of the stuff that you can do right now is this kind of thing. You can put up a solar canopy instead of putting up a new outbuilding. And so if you're a farmer and you're looking at a new drive shed, we can get a similar cost on this. Our engineering team is looking at solutions to make it more for season, not necessarily full walls on the side, but we are looking at what it might look like to put fabric around the outside and do some covered storage. On a building that's going to pay you back rather than just be an investment that kind of soaks up the cash for a while. So here's one of them. All right. So here you're getting a look at what we can accomplish with our rail system. So when we redesigned the canopy solution that we started off with back at our first install in 2018, one of the things we knew we wanted to solve for was water management. The first year after that canopy went in, there were icicles, pretty big icicles coming down, and it's because in between the panels, the water would drip through. Drips are annoying, but icicles can be a liability, especially if you're putting cars or kids or pets or something like that underneath of them. Anyways, solving for water management, we came up with this. So it's a continuous rail system. It supports the long edge of the panel. And we were able to spread the purlins further apart and reduce our material cost at the same time by spreading out the purlins. So there's some cost savings there. But what we're able to integrate is these little channels on the side. So anywhere that there is some water that comes down between panels, It's going to find its way to these channels, and we can take it to the edge of the array there. At that point, it can be sent to stormwater, it can be used for gray water, it can be used for irrigation, and this is something that, in terms of an agrivoltaics application, we feel like we can bring some good value. There's going to be some places where you don't want to have all the water falling off and kind of creating a bit of a trough or a spot where there's a lot of water dripping. We can solve for that. Other spots you may want to keep some things dry. So if we're looking at covered outdoor storage or animal shelters, again, this is something that we feel like we can bring in terms of value to the agrivoltaics world. So we can bring this to a greenhouse sort of situation as well. So if we're looking at integrating greenhouse and PV together, we could do a roof of a greenhouse with this trough system that we've got. And we think that there's a lot of space there to integrate more and more PV into greenhouse settings. And we haven't done this yet, so we'd love to chat more with people who are active in this space about how we might integrate what we've got going on. But this is a big opportunity. Greenhouses take up a fair bit of space in certain areas, and there's a lot of roof area there. And there tends to be a fair bit of energy-intense usage from lighting and heating systems as well. And so we feel like the use case is there for this sort of system. The rail system would work on walls as well. It would be kind of case by case whether or not it makes sense, but we feel like we've got what it would take to get them up and do some walls with this sort of structure as well. I'm just going to click through these quickly, but it gives you a sense of what it could look like. And then we feel like there's room kind of at a winery, for a covered patio, for a building entrance, for a walkway entrance, for bike parking, where our designs will fit in. And we're looking for some of those spaces where you might put up some other kind of structure that doesn't pay you back, that doesn't make energy, and put up one of these instead. In terms of how that relates to crop growth, we're exploring that space. We don't pretend to be experts in that space at the moment. We're here because we want to have conversations. We want to talk to people who really do know. But we feel like we've got a fair bit of versatility in our designs. We've got a number of different designs already engineering approved. And we feel like with some good conversations and being in the right room at the right time, that we can adapt those designs and find some things that's going to work in a variety of different settings in agriculture.
I think we have time for maybe one very short group discussion. So is it specifically about...
Yeah, about the solar canopy. Does it actually meet the requirements of a rooftop solar under the current definition? Right? Because it's got to be a purpose, or you have to have a purpose for the building. Does that qualify?
Yeah, so these are buildings as opposed to ground mount solar. We've been careful to design them that way so that we don't have to do the approval process for ground mount solar. So they are buildings.
They are buildings.
Yeah.
Because I want to keep this short, we've got innovators on the panel, all different types of innovation. I wanted to know your thoughts on, is there one sort of innovative application either for agrivoltaics or some other technology kind of coming in that could affect agrivoltaics that would really drive this kind of industry forward? In what you've seen and the kind of applications that people are coming to you for, what's kind of the next killer app innovation that you might see coming to the table that you might want to develop or you might want to connect to?
I think one of the things that we're seeing a huge increase in requests is like the 2P tracker, like a two portrait tracker, but also to, I think it was mentioned earlier, for the cattle farms. We've got a lot of those requests where you can raise them up to, I believe someone said here 7 feet, and in our R&D we're raising it up to almost 8 feet, where I think, Kevin mentioned that. You were mentioning this. The 2P tracker, we're seeing a lot of interest in that. We're seeing a lot of interest in how the cattle's, we have for example, in our case, we have a drive shaft design. We don't have a torque tube, so that drive shaft is also elevated to a point where the cattles are not harmed and can easily glaze underneath. That's the one thing that I'm seeing a big demand for. And the other one, which is Dr. Pierce, I think is kind of pioneer in this, is a little bit more of monitoring on the crops. Like you build something where I think the umbrella application, and you have kind of cameras or whatever the case to monitor those crops, whether it's apples, whether it's berries, whatever the case is, and kind of sends you like an alarm. Is like, hey, I think it's ready, or it needs a little bit of sun, it needs a little bit more of moisture, and then accordingly you would work with your controllers and you would work with your machine learning application to to meet whatever demand there is. Not sure if you had a
Yeah, I can jump in.
Yeah.
So this is a little out there, but I was on a panel earlier this fall with a lady who's a bee researcher at University of Waterloo and I think Arizona as well, but kind of southern U.S. And she's working to aggregate data from beekeepers around the world and learn about what kind of plants the bees are getting to by using her app and this research. And I think that there's an interesting space where agrivoltaics, solar and agriculture, and some of the data that's coming out from this kind of research can work together, where we know what kind of plants are in that area. So how far should we space things out? And as more and more of these sorts of things come online, I think there's a tremendous opportunity to just do better and better and get more and more efficient with how we're designing the system. So I'm looking forward to seeing more of that in the future.
Yeah, I think when I look at innovation, what has been, I think, identified over the last couple of years in particular when it comes to controlled environment agriculture, there's been a number of fairly large players in this sector. Actually, some of the largest controlled environment agricultural setups in the U.S. and in Netherlands shut down. They went bankrupt. When I was on a fantastic call a few weeks ago where some of the leaders from those companies actually shared why the companies were not successful, and I was so appreciative of their candor. The number one factor was electrical costs. That when the companies set up, there was wonderful intention, but as electrical costs rose, they were not able to keep scale with it. You've got to grow an awful lot of lettuce to keep up with some of the electrical costs that were coming through, especially the companies that had large robotics. I love robots. I know there's a couple of our robot friends in the room here today. I love a robot that can serve the farmer and make the farmer's life easier. But there's got to be a balance. And what they were finding was the cost of the electricity made it unviable. They were unable to get a return on investment. The other thing was staffing. That, the cost of human resources, and in some of these large-scale farms, they were having to employ robotics engineers as opposed to farm help. And again, that threw their return on investment out. So what I think is really exciting is the opportunity to combine controlled environment agriculture, which brings crops inside and protect them. It's very similar to a greenhouse, except for instead of hoping that you get sun today and hoping that you can control the heat, or hoping that your air conditioning and your venting can get the heat out, or that you don't get a hailstorm, you bring it into a building that you can control those factors much better. Now the trade-off is that, yes, you do need to have supplemental lighting, you need to have lights. And that's why I think it's really exciting, the opportunity to work with photovoltaics and particularly agrivoltaics, because it really provides the opportunity to maximize food production in multiple streams. And for me, I think when I look at innovations that are coming down the way, both here in Canada and around the world, electricity is it. That is the number one thing that everybody is talking about everywhere that there's discussions about controlled environment, ag food. And so continuing the work that's happening here and being able to produce more electricity efficiently and protect our crops is going to be a big innovation that I think we'll see happening all over the place.
I guess it has to be within two stages. The first stage is to make farmers feel very comfortable with combining power with agriculture. That's the first thing, which is a paradigm shift. It's not easy to change paradigms in the industry, but it's a paradigm shift. I think, and the second one is, as Sam mentioned, basically controlling it, making them smart smart farms and controlling humidity and everything else and basically monitoring it online, basically.
So I want to turn it over to the audience. We only have about 10 minutes left, so I wanted to give you some opportunities to ask questions.
So for those vertical trackers or those vertical structures that you have for the panels, you mentioned that bigger foundations are required and stuff. So what is the anticipated cost increase or cost difference between the standard one tracker versus those vertical structures, just in terms of the structure cost itself and foundation?
Yeah, foundation definitely has to be like bigger and thicker. From racking perspective, it's basically cheaper because now we're going to be doing vertical. Now I'm not going to give you any number here, but it is a little bit more expensive. We're trying to bring it down and making it the same level as what the fixed tilt is.
Just to be clear, your ask was vertical, like the fence design versus a 1P tracker?
This is 1P tracker or fixed, doesn't really matter. So I think you answered my question.
Yeah, I think, yeah. Just like it's all under R&D right now, right? But like the fixed tilt versus the fence design, my goal is to have the fence design much cheaper than the fixed tilt. Not much, but more affordable than the fixed tilt, basically.
Following up on the fence design, I'm just thinking like spacing is super critical there, right? If you're vertical, like you have to have a fair bit more spacing. Do you have a sense as to, and I know, researching and, it's kind of new, but do you have a sense as to what optimal applications are and how much spacing do you need to accommodate, this?
Currently, our design is set for 15 meters. Between the two fences, row-to-row spacing is about 15 meters. That's how we did our analysis.
And is it height dependent? Like if you're taller, if you have to have a 3-foot there, it's a lot of.
Now, the good thing about agrivoltaic is, I mean, the land is already disturbed, and it's been used in farm. So it's fairly flat. Yes, you would have up and downs, and we can accommodate that. But right now, the way we're taking it, like about maybe 5-6% grade across the place, and that's how we came up with the 15 meter.
Are the foundations for the fence racking greater than what you would need just for snow or the frost line or whatever? Is it more than what you have to do normally?
Well, again, it depends from where you're building it, right? But if you compare apple to apple, it is more or less the same depth as what we have before. Like we can use various different types, like helical, screw, driven, but in terms of thickness and diameter, it increases because you would need to withstand. Remember, you don't have snow anymore, snow loads to take care of because it's vertical. But you would have more wind load that you have to take care of.
We use this longer distance between rows, right? In between panels, but in the same acre, you have the same production, or you need more acre to produce at the same level.
So basically acre versus like let's say a 5 megawatt or 1 megawatt is built on a 5-acre land. What is I forgot the design we did for a fence design. 1 megawatt. How many acres was that?
I don't recall.
Yeah,
but I can
give you that number because we have design.
Similar numbers because you have more space in between, right?
It would. It's very.
Vertical instead spreading in the air, right? So based on the air, you have the same or similar production.
It's about that, yeah, because I know I compared it versus a tracker project and it was very comparable, but I can give you the numbers in more accurately after the session. It's a good question.
Maybe to add to that, I know that we've played around with that ourselves, and it also really is influenced by what the use case is. So I don't, I can't speak for 15 meter spread spacing, but I know we've discussed, 120, 130 foot spacing if you're looking at kind of accommodating like Western large scale agriculture. So it really, you've been in those conversations, they've been all over the place in terms of what your density, but I certainly couldn't speak to how much you could get per acre, but
It would be less energy density.
But if you have like Chris would know better numbers about that, but like in between the panels, you have kind of 4 meters between, right? Plus under the panel. So you already have that, so like 5 plus, let's say 2 plus 2 on the other side, so you're almost there, almost the same.
Exactly.
Like, that's why my question is almost the same.
It's design requirement driven. Whatever the design requirements, it's, you get the results. But yeah, you're right.
Because with that, on the sheep perspective, it's a way easier way to bigger equipment, so it's make a huge difference.
15 meters is not a set number. That's how we designed it. That's why we started evaluating one against the other, right? But you can do whatever you want, and you can analyze each one with a PVC and see like where you're at with shading and everything.
Because it's in vertical, do the material need to be stronger or the same material to protect for the panels is the same?
We're using the same material as a fixed.
Maybe 1 or 2 more questions.
I was just curious, a lot of like the existing projects, we're facing kind of a big issue where panel manufacturers are making them bigger, more large, and all of our existing racking doesn't fit the puzzle, right? So what's your guys' like offerings to combat that, or what do you see existing projects having to do to retrofit if they wanted to incorporate agrivoltaics? Do you rip it all out, or do you just create a retrofit solution?
Yeah.
Do you want to answer that?
Go ahead.
Yeah, it's a very good question. For our existing designs, we're designing for like the 650 and the 700 watt panels, and we don't have an issue with it. But to retrofit a project, it would highly depend on what the module is. Like I think about a year and a half ago, someone came up to me with it's like, hey, we want to retrofit this 2P tracker, dual axis tracker it was. And he said, I need some help with designing some purlins and whatnot. And the panels he had on that, 180 watt module. So I don't know, it was built like 2010 or something. It was a little bit challenging. It was a little bit challenging because you do have to rip it all off. You do have to add in new snow loads. You to calculate the new snow loads and wind loads. You need to replace the purlins. You need to adhere to the solar panel manufacturer requirements, where the green zone is and where to clip the module and all of that stuff. I would say it's case by case, but for a new build, it's easy, very easy to accommodate the 650, the 700 watt panels, and more than this.
Are they adjustable so that way, like in 10 years, they're even bigger?
No, we're not being asked to do this. No, we're not. That's IKEA stuff. Sorry, did you have it? No, okay, sorry.
So I think we're pretty close to lunch. Was there any other question to finish?
I might just ask one topic we hasn't come up in this when we're talking about traditional agriculture, like cash cropping mixed with solar, is the issue of soiling. So you've got brownfield for 8 months of the year. As in terms of the experience in the panel, or maybe from the audience, but I mean that is a big issue where you've got soiling, you've got bifacial modules. If you're a fence design or traditional design, those panels are going to be unlike any others that we've deployed on ground. So is that fitting into discussions that you guys are having with developers at all?
Soiling losses?
Well, it's the issue of soiling that is specific to agrivoltaics, where you've got tilled land that lies bare, not growing anything for 8 months of the year, and then you've got you've got, you got green cover for 4 months of the year.
I'm not sure I understand that question correctly.
So when you till the field,
Right.
and you plant, you have coverage. Where
Right.
a traditional solar farm would have coverage all year round. It's
Right.
just managed. Whereas on a field, you're clearing that out, and 8 months of the year is just brown soil. And so his concern is, does wind pick that up and transfer it to the modules? Yeah.
Sorry?
It's not a question of if.
By how
Yeah,
much?
of course. By how much?
Soiling will be a different level of issue than it is in a typical ground mount.
Yeah, in our PVSys model, the numbers that Dikran showed, we just assumed the normal losses, just to be completely transparent. We didn't assume any if they're cutting the grass or whatever the case is, how much of that is just being transported to the panels, and what would be the losses. That was not accounted for.
It did though have in there like snows and all the other things that you see during the winter time. You would see like much reduced power in winter, because some days you will have the whole thing covered until it melts and so on. It takes into consideration those things. But
I wonder too, especially with the fence type configuration, if you get more like faster runoff and the modules get, slightly better cleaned as a result. But
You get a snow fence effect though too, right? So you get driven snow, and you'll find, particularly in an east-west fence configuration, you'll get bonded, like the snow will bond as ice. And we've seen that in the northeast US just on tractors where they're shut down for the month because wind-packed snow does not come off. So I mean, it's weather dependent what type of winter you're going to have. So.
awesome.
Good feedback. Thanks.
Well, I'd like to thank everybody for your contributions to the conversation and to our esteemed panel's expertise in this. It's lunchtime now, correct? Yeah. It's 12 o'clock, so my belly's saying it's lunchtime. How long are we out for? 1 hour. For 1 hour. So we'll restart here at 1 o'clock, and we have an hour to network. Thank you so much.